Article 210.8 addresses dwelling units requiring ground fault circuit interrupter, or GFCI, protection for all 125 volts, 15 amps and 20 amps receptacles in unfinished basements, crawlspaces, and detached garages. Article 210.8b, however, addresses locations other than dwelling units. It specifies GFCI protection for all 125 volts, 15 amps and 20 amps receptacles in bathrooms, kitchens, and other locations where moisture or dampness are present. Applying this to a commercial crawlspace, it's crucial to understand that a commercial crawlspace is not a dwelling unit. Therefore, the requirements of 210.8 do not directly apply. However, if the crawlspace contains heating, ventilation, and air conditioning or HVAC equipment and a sump pit, it can be reasonably considered a location where moisture or dampness is present. Based on this code interpretation and the potential for moisture in the crawlspace, it is recommended that GFCI protection be provided for the service receptacles installed in the crawlspace. GFCIs offer increased protection from electrical shock, especially in environments where moisture or dampness can compromise electrical safety. HVAC equipment and sump pits are likely to generate moisture, which could create a hazardous environment for anyone working in the crawlspace. Providing GFCI protection is a proactive measure to ensure the safety of maintenance personnel and other individuals who may access the crawlspace. It is important to note that while the code may not explicitly require GFCI protection for receptacles in commercial crawlspaces, it also does not prohibit it. In the interest of safety and code compliance, it is considered a best practice to install GFCI protection in such installations. This approach aligns with the broader intent of the electrical code, which prioritizes safety in potentially hazardous environments. Consider the operational characteristics of HVAC equipment and sump pumps. HVAC systems often generate condensation, especially during cooling cycles. This condensation can accumulate in the crawlspace, leading to increased humidity and dampness. Sump pumps, by their very nature, are designed to remove water from the crawlspace. However, their operation inherently involves the presence of water, which can increase the risk of electrical hazards. Crawlspaces themselves tend to be damp environments due to their proximity to the ground and limited ventilation. This inherent dampness, combined with the moisture generated by HVAC equipment and sump pumps, creates an environment where the risk of electrical shock is elevated. Electrical codes are designed to address potential hazards. While the code may not explicitly mandate GFCI protection in all commercial crawlspaces, it does emphasize the importance of protecting against electrical shock in damp or wet locations. By providing GFCI protection for receptacles in a commercial crawlspace with HVAC equipment and the sump pit, you are exceeding the minimum requirements of the code and demonstrating a commitment to safety. This approach can also mitigate potential liability issues. If an electrical accident were to occur in the crawlspace, the presence of GFCI protection could demonstrate that reasonable precautions were taken to prevent injury. Several factors should be considered when selecting and installing GFCIs in crawlspaces. Firstly, ensure that the GFCIs are rated for outdoor use. Crawlspaces, even if enclosed, can be exposed to moisture and temperature fluctuations. Secondly, install the GFCIs in readily accessible locations. This will facilitate testing and maintenance. Thirdly, use weatherproof covers for the receptacles to protect them from moisture and debris. Regularly test the GFCIs to ensure that they are functioning properly. The manufacturer's instructions will provide guidance on testing procedures. Additionally, consider using a GFCI circuit breaker to protect the entire branch circuit that serves the receptacles in the crawlspace. This approach provides an additional layer of protection. In addition to GFCI protection, ensure that all electrical wiring in the crawlspace is properly installed and maintained. Use appropriate wiring methods for damp locations, such as Type UF cable or conduit. Secure the wiring to the building structure to prevent damage. Ground all electrical equipment in accordance with the code requirements. Proper grounding helps to minimize the risk of electrical shock. Furthermore, implement a regular inspection program for the crawlspace. Look for signs of moisture, damage to electrical equipment, and other potential hazards. Address any issues promptly to prevent them from escalating. Consider installing a moisture barrier in the crawlspace to reduce the amount of moisture that enters from the ground. A moisture barrier can help to create a drier and safer environment. Educate maintenance personnel and other individuals who may access the crawlspace about the potential electrical hazards and the importance of following safe work practices. Provide training on how to properly test and reset GFCIs. Post warning signs in the crawlspace to alert people to the presence of electrical equipment and the need to exercise caution. Consult with a qualified electrical contractor to ensure that all electrical work in the crawlspace is performed in accordance with the code requirements and best practices. An experienced contractor can assess the specific conditions of the crawlspace and recommend appropriate safety measures. Remember that electrical safety is an ongoing process. By taking proactive steps to protect against electrical hazards, you can create a safer environment for everyone. Always prioritize safety when working with electricity. If you are unsure about any aspect of electrical work, consult with a qualified professional. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals for specific applications and code interpretations. Ground fault circuit interrupters, or GFCIs, are an essential safety device designed to protect individuals from electrical shock. They work by monitoring the current flowing in a circuit and quickly interrupting the power if a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are designed to detect even small ground faults and trip the circuit within milliseconds, preventing serious injury or death. There are two main types of GFCIs: receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard electrical outlets and provide protection only at that specific location. Circuit breaker type GFCIs are installed in the electrical panel and provide protection for the entire circuit. Both types of GFCIs offer the same level of protection, but circuit breaker type GFCIs are more convenient for protecting multiple outlets or appliances. When selecting a GFCI, it is important to choose one that is rated for the intended environment. GFCIs are available in indoor and outdoor models. Outdoor GFCIs are designed to withstand exposure to moisture and other elements. It is also important to choose the GFCI that is compatible with the existing electrical system. GFCIs are available in different voltage and amperage ratings. The GFCI must be rated for the same voltage and amperage as the circuit it is protecting. Installing a GFCI is a relatively simple process, but it is important to follow the manufacturer's instructions carefully. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the GFCI. Once a GFCI is installed, it is important to test it regularly to ensure that it is working properly. Most GFCIs have a test button that can be used to simulate a ground fault. When the test button is pressed, the GFCI should trip and interrupt the power to the circuit. If the GFCI does not trip, it may be defective and should be replaced. GFCIs are an important safety device that can help to prevent electrical shock. By installing GFCIs in areas where there is a risk of moisture or dampness, you can significantly reduce the risk of electrical injury. Remember to test GFCIs regularly to ensure that they are functioning properly. In addition to GFCIs, there are other safety measures that can be taken to protect against electrical shock. These include using properly grounded electrical equipment, avoiding the use of extension cords in damp or wet locations, and keeping electrical appliances away from water. By following these safety precautions, you can help to create a safer environment for yourself and others. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to consult the NEC when planning any electrical work. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical installations. Following the NEC helps to ensure that electrical systems are safe and reliable. Local jurisdictions may also have their own electrical codes that supplement the NEC. It is important to check with the local authorities to determine the applicable electrical codes in your area. Electrical inspections are typically required for new electrical installations and renovations. Electrical inspectors verify that the electrical work complies with the applicable codes. Passing an electrical inspection is essential for ensuring the safety and legality of electrical installations. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An experienced electrician can perform electrical work safely and efficiently. Electrical safety is a shared responsibility. By following safe work practices and taking proactive measures to prevent electrical hazards, you can help to protect yourself and others from electrical injury. Always prioritize safety when working with electricity. If you have any questions about electrical safety, consult with a qualified professional. The principles discussed here apply broadly to various types of commercial buildings. While the specific example focuses on a crawlspace, the underlying considerations regarding moisture, equipment, and safety are relevant to other areas as well. For instance, commercial kitchens, laundry rooms, and areas with process equipment often present similar challenges related to moisture and electrical hazards. In these locations, careful attention to GFCI protection, wiring methods, and grounding is essential. Additionally, consider the specific use of the space when determining the appropriate level of electrical safety. Areas with heavy foot traffic or frequent maintenance activities may require more robust protection measures. Regular inspections and maintenance are crucial for ensuring the ongoing safety of electrical systems in commercial buildings. Over time, wiring can deteriorate, connections can loosen, and equipment can fail. Regular inspections can help to identify potential problems before they lead to accidents or equipment damage. Maintenance activities, such as tightening connections, replacing worn wiring, and testing safety devices, can help to keep electrical systems in good working order. It is also important to keep accurate records of electrical work performed in the building. These records can be helpful for troubleshooting problems and planning future upgrades. Building owners and managers have a responsibility to ensure the safety of their tenants and employees. This includes providing a safe electrical environment. By taking proactive steps to address electrical hazards, building owners and managers can help to prevent accidents and injuries. This not only protects people, but also helps to reduce liability and maintain the value of the property. Furthermore, consider the impact of energy efficiency on electrical safety. As buildings become more energy efficient, new technologies and equipment are being introduced. It is important to ensure that these new technologies are installed and used safely. For example, LED lighting can significantly reduce energy consumption, but it is important to choose high-quality LED fixtures that are properly grounded and protected from moisture. Similarly, variable frequency drives, or VFDs, can improve the efficiency of motors, but they can also generate harmonics that can affect the performance of other electrical equipment. Careful planning and coordination are essential for integrating new technologies into existing electrical systems. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals for specific applications and code interpretations. Electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that electrical systems are safe and compliant. Professional organizations such as the National Fire Protection Association, or NFPA, offer resources and training to help electrical professionals stay informed. Continuing education is essential for maintaining competence in the electrical field. By investing in training and education, electrical professionals can enhance their skills and knowledge and provide better service to their clients. Electrical safety is a continuous process of learning, adaptation, and improvement. By embracing a culture of safety and staying committed to professional development, electrical professionals can make a significant contribution to the safety and well-being of their communities. Always prioritize safety when working with electricity. If you have any questions about electrical safety, consult with a qualified professional.